Time doesn't flow. That's the first thing you need to understand. That steady tick of the clock, the relentless march of seconds into minutes, into hours. It's all an illusion. A convenient fiction we've created to make sense of a reality far stranger than we're equipped to comprehend. What if I told you that everything you understand about the fundamental nature of existence is based on a profound misunderstanding? That time, the dimension we believe carries us from birth to death, from past to future, might be capable of existing entirely without space? The very thought shatters the foundations of physics as we know it. But to truly grasp this possibility, we must first unlearn what we think we know. Consider this. You've never actually seen time. You've seen its effects, the wrinkles deepening on your face, the steady decay of matter, the constant transformation of energy, but time itself remains invisible, untouchable, a phantom dimension we experience but cannot directly observe. Now, imagine space suddenly vanished. Not the contents of space, the stars, the planets, the endless void between galaxies, but the fabric of space itself. The three dimensions that give objects position, that allow movement, that create the concept of where. Would time continue its relentless forward march? Or would it, too, dissolve into nothingness? The Big Bang didn't bang. There was no explosion, no sound, no flash of light illuminating a pre-existing darkness. There was no before the Big Bang, in any meaningful sense that human language can articulate. Time and space didn't exist independently, and then decide to join forces. They emerged together, intertwined, inseparable. At least, that's what conventional physics tells us. But what if that fundamental assumption, that time and space are forever bound in an eternal dance, is wrong? What if these dance partners could exist without each other? What if time could flow without having anywhere to flow to? Rewind to the beginning. Further, past the formation of galaxies, past the first stars igniting in the darkness, past the moment when the universe became transparent to light. Further still, to that initial singularity, the infinitely dense, infinitely hot point from which all reality emerged. If you could witness this moment, what would you see? Not creation, but transformation. Not a beginning, but a boundary. A horizon beyond which our understanding of physics breaks down completely. The mathematics becomes singular, meaningless. Our equations scream in protest, unable to describe what lies beyond that threshold. You exist in 4 dimensions, 3 of space, 1 of time. You move freely through space, forward, backward, up, down, side to side. But time drags you in only one direction, always forward, never back. Why this asymmetry? Why can you revisit the place of your birth but never the moment? Einstein showed us that space and time are aspects of a single entity, spacetime. The faster you move through space, the slower you move through time. Near the event horizon of a black hole, time nearly stops for an outside observer as space becomes infinitely curved. These dimensions seem inextricably linked. But are they? Imagine being trapped in a timeless prison, a place where nothing changes, nothing moves, nothing evolves. No thoughts form, no hearts beat, no light travels. This is a universe without time, frozen, static, eternal. Now imagine the opposite. A reality with time, but no space. No distances to travel, no positions to occupy, no directions to move in. What would exist in such a reality? Could consciousness persist? Could change occur without a stage on which to unfold? Physics as we understand it offers no clear answers, only contradictions and paradoxes that push the boundaries of human comprehension. The universe is expanding, but into what? There is no outside the universe, no empty container being filled as space stretches. The universe doesn't expand into anything. Space itself expands. Every point moves away from every other point, like dots on the surface of an inflating balloon. But a balloon expands into the third dimension. What higher dimension does our universe expand into? Or is this question itself meaningless, a product of our limited three-dimensional thinking? If space can expand without expanding into anything, could time exist without flowing through anything? Quantum mechanics has revealed a reality at the smallest scales that defies our intuition. Particles that exist as probability clouds until observed. Entangled particles that communicate instantly across vast distances, seemingly violating the speed of light. Time at the quantum level behaves differently than the time we experience in our macroscopic world. Some interpretations of quantum mechanics suggest that time may be an emergent property, not fundamental, but arising from more basic quantum processes. If time isn't fundamental, could it exist independently of space? Or is the very question based on a flawed understanding of what time actually is? Your brain processes reality with approximately a 80-millisecond delay. What you perceive as now is actually the recent past. Your consciousness stitches together these delayed perceptions to create the illusion of a continuous, flowing present. But this now doesn't exist objectively in the universe. Einstein proved that simultaneity is relative. Events that appear simultaneous to one observer may occur at different times for another, depending on their relative motion. There is no universal now that all observers would agree upon. The present moment, that knife edge between past and future that seems so real, so immediate, is merely a psychological construct, not a fundamental feature of reality. Close your eyes. Imagine the entire history of the universe, from Big Bang to heat death, printed on a vast cosmic film strip. Each frame represents a single moment in time, a complete snapshot of the universe at that instant. Now imagine viewing this film strip not from within, as we do in our everyday experience, but from outside, seeing all moments simultaneously with no privileged now. This is how many physicists believe time actually exists, not flowing, but simply being. Not a river carrying us from past to future, but a landscape where all moments exist with equal reality. If this block universe view is correct, then time doesn't flow at all. It simply is. And if time doesn't flow, could it exist independently of the spatial dimensions that seem to give it meaning? The question remains, could time exist without space? To answer, we must venture beyond the comfortable confines of established physics, beyond Einstein's relativity and quantum field theory, into the speculative realm where mathematics meets philosophy. We must confront the possibility that time, as we understand it, is merely a shadow, a partial, distorted reflection of something far more fundamental and strange, something that might indeed exist independent of the spatial dimensions we take for granted, something that might force us to reimagine the very foundation of reality itself. To understand the relationship between time and space, and whether one could exist without the other, we must first journey back to the moment when both were born. Modern cosmology tells us that 13.8 billion years ago, our universe erupted into existence. But this isn't merely ancient history. It's the foundation of reality itself, the cosmic bedrock upon which everything you know has been built. The laws of physics, the constants that govern atomic behavior, the four fundamental forces, all emerged from that primordial moment. It's a scientific truth we've come to accept without question. Time and space were born together. twins from the same cosmic womb. Yet this certainty begins to unravel when we examine it closely. The early universe wasn't just hot. It was a furnace where time itself was still learning to move. In those first fractions of a second, when the entire cosmos was compressed to a volume smaller than an atom, our familiar notions of before and after began to blur. Temperature and energy density reached such extremes that our current physics cannot describe what happened. It's not merely a gap in our knowledge, it's a fundamental boundary of understanding. The equations that so elegantly describe today's universe break down completely, leaving us with mathematical singularities, infinities that appear like cosmic error messages in our calculations. Imagine the universe as a vast cosmic tapestry. Every thread represents a dimension. 3 for space, 1 for time. They weave together to create the fabric of reality as you experience it. Now try to imagine removing just the spatial threads while keeping the temporal one intact. Could such a tapestry still exist in any meaningful sense? Or would it unravel completely, leaving nothing behind? Einstein's relativity suggests the latter. His equations don't treat time as something separate from space, but as part of a unified whole, space-time. The curvature of space-time creates what we experience as gravity. Massive objects like stars and planets bend this fabric, causing smaller objects to fall toward them, not because of some mysterious attractive force, but because they're following the natural contours of a curved reality. When a black hole forms, space-time curves so extremely that it creates a singularity, a point where space and time cease to exist as separate entities. As you would approach a black hole's event horizon, time would stretch and distort relative to observers far away. What would be minutes to you would be years, centuries, or even eons to them. This isn't science fiction. It's a direct mathematical consequence of Einstein's field equations. Time and space twist together so completely that separating them becomes meaningless. The black hole teaches us that these dimensions aren't just connected, they're aspects of the same fundamental reality. But quantum mechanics tells a different story. At the smallest scales, space becomes grainy, quantized, built from indivisible units rather than the smooth continuum we perceive. Time, too, may be quantized, existing in discrete ticks rather than flowing continuously. These quantum grains of space and time are inconceivably small, billions of times smaller than a proton. Yet they could be the fundamental building blocks of reality. Here's where the mystery deepens. Some theoretical frameworks suggest these building blocks might not be equally fundamental. What if space emerges from more basic quantum processes, while time reflects something more primitive? Could this mean that time might exist in realms where space, as we understand it, does not? The ancient philosophers believed time was merely the measurement of change. No change, no time. This intuitive definition served humanity well for millennia. But modern physics has revealed a universe far stranger than those philosophers could have imagined. Consider quantum entanglement, the phenomenon Einstein famously called spooky action at a distance. When particles become entangled, they share a single quantum state, regardless of how far apart they are. Change the state of one, and the other changes instantly. Not at the speed of light, but truly instantaneously. This seems to violate everything we understand about space and time. How can information travel faster than light? The answer may be that at the quantum level, space itself is an illusion, a macroscopic approximation that breaks down at the smallest scales. If space is negotiable at the quantum level, might time be the more fundamental reality? Or perhaps neither is fundamental, and both emerge from something deeper still. Think of reality as a cosmic hologram. a three-dimensional projection of information encoded on a two-dimensional surface. Just as a holographic image appears to have depth when viewed from the right angle, our four-dimensional spacetime might be a projection of something more basic. This isn't mere speculation. It's a serious proposal in theoretical physics known as the holographic principle. If true, it suggests that space and time aren't fundamental aspects of reality, but emergent properties arising from quantum information. The universe is expanding at an accelerating rate. This is perhaps the most profound discovery in modern cosmology, and the most puzzling. What force could be powerful enough to overcome gravity and drive galaxies apart with increasing speed? Physicists call it dark energy, but the name is merely a placeholder for our ignorance. We don't know what it is, only what it does. And what it does challenges our understanding of space and time in profound ways. If the expansion continues to accelerate, eventually every galaxy beyond our local group will recede faster than light can travel. They won't just be invisible, they'll be unreachable in principle. Space will stretch so rapidly that even light will never cross the growing gulf between cosmic islands. This cosmic expansion raises a disturbing question. If space can stretch indefinitely, what happens to time? Does it stretch as well? Or does quantity it maintain its steady beat as space itself unravels? The answer lies in how we understand the most fundamental equations of physics. In Einstein's theory, time isn't just intertwined with space. It's a dimension of the same geometric entity. But when we try to reconcile Einstein's relativity with quantum mechanics, we encounter profound contradictions. At the quantum level, time behaves differently than in the macro world. It becomes fuzzy, uncertain, almost as if it's not fully real. If the universe has no edge, then where does it begin? This seeming paradox emerges when we try to visualize cosmic inflation, the moment just after the Big Bang, when the universe expanded faster than light. Not because anything was moving through space, but because space itself was stretching at superluminal speeds. There was no outside for the universe to expand into. Every point was moving away from every other point. The beginning wasn't a place, it was a state of the entire cosmos. And if the beginning wasn't a place, could it have been a time without a place? Could the temporal dimension have preceded the spatial ones? The concept of time existing without space becomes less absurd when we consider abstract mathematical spaces. In the formalism of physics, we routinely work with configurations that have temporal evolution but no physical extension. Phase spaces, Hilbert spaces, configuration spaces. These mathematical constructs allow us to describe systems that evolve through states rather than positions. They suggest that time-like progression might exist in realms that bear no resemblance to physical space as we know it. Perhaps what we call time is merely our limited perception of something far more general. The evolution of states in a realm where has no meaning, only when and what. Here's a profound thought experiment. Imagine a universe consisting of nothing but a single quantum particle in perfect isolation. This particle has internal states that can change. Perhaps it spins or vibrates according to quantum principles. There is no space in this universe, no distance or direction, only the changing states of this solitary particle. Would time exist in such a reality? If those states change in a sequential, orderly fashion, wouldn't that constitute a form of time, even in the complete absence of space? This isn't merely a philosophical curiosity. It gets at the heart of what time actually is. Is time the progression of physical systems from one state to another? Or is it something more fundamental, something that would persist even if space itself dissolved into nothingness? As we contemplate these questions, we begin to see that our intuitive understanding of time and space, so useful in navigating everyday life, becomes hopelessly inadequate when applied to the cosmos as a whole. The universe doesn't just contain mysteries. It is a mystery, one whose fundamental nature might forever exceed our capacity to comprehend fully. Yet we continue to probe these depths, driven by the uniquely human desire to understand our place in the cosmic order. And as we do, we edge closer to an unsettling possibility. That time, that most familiar dimension of our existence, might be capable of flowing through realities where space as we know it has no meaning at all. The universe whispers its secrets in the language of mathematics. Equations that describe reality with such precision that we can predict the existence of particles decades before we build machines powerful enough to detect them. But when we turn these mathematical tools toward the most fundamental questions about time and space, they begin to reveal paradoxes so profound they shake the foundations of physics itself. These aren't mere puzzles to be solved. They're windows into the true nature of reality, and they suggest possibilities far stranger than we ever imagined. Imagine reality as a film reel, where time is not flowing, but every moment already exists. Past, present, future, all printed on frames, eternally fixed. This is the block universe theory, first suggested by Einstein's special relativity. In this view, time doesn't pass. Rather, events are fixed in a four-dimensional block where the past and future are as real as the present. Your birth, your death, and this very moment of awareness all exist simultaneously in this eternal tapestry. You don't move through time, you're extended through it, like a sculpture stretched across the fourth dimension. This theory solves certain paradoxes of relativity, particularly the relativity of simultaneity. But it raises a chilling question. If the future already exists, was your fate determined before you were born? And more germane to our exploration, if time is merely a dimension like space, could one exist without the other? Or are they merely different perspectives of the same underlying reality? When light passes near a black hole, its path bends dramatically, creating what astronomers call gravitational lensing. But it's not just light that bends. Time itself curves in the presence of mass. Every object in the universe, every star, planet, and grain of sand, warps the fabric of space-time. The Earth creates a dimple in this fabric, which is why objects fall toward its center. The Sun creates a deeper well, which is why planets orbit rather than flying off into interstellar space. These aren't metaphors, they're precise mathematical descriptions encoded in Einstein's field equations, and they reveal something profound. Time isn't separate from space, but is woven into its very fabric. Near massive objects, clocks run slower, not because of any mechanical effect, but because time itself flows differently. GPS satellites must account for this effect to maintain accuracy, adjusting for the fact that time passes slightly faster in orbit than on Earth's surface. This isn't theory, it's engineering necessity. But Einstein's elegant equations break down completely when we approach singularities, points where density becomes infinite, and space-time curvature reaches extremes beyond mathematical description. These occur at the center of black holes, and, theoretically, at the moment of the Big Bang itself. Here, time and space cease to exist, as we understand them. Our mathematics cannot penetrate these regions because the very concepts they're built upon dissolve into meaninglessness. It's as if reality itself has a boundary, not a physical edge, but a limit to what can be described within our current framework of physics. Beyond this boundary may lie the answers to our deepest questions, including whether time could exist independently of space. But to reach those answers, we must venture beyond Einstein into the quantum realm. Consider the double-slit experiment, perhaps the most profound demonstration of quantum weirdness ever devised. Send individual particles, electrons, photons, even entire molecules, through two parallel slits, and they create an interference pattern as if they were waves passing through both slits simultaneously. But place detectors at the slits to observe which path each particle takes, and the interference pattern vanishes. The particles behave as if your observation forced them to choose a single path rather than taking all possible paths at once. This isn't a limitation of our measuring equipment or some bizarre experimental artifact. It's a fundamental feature of quantum reality. The act of measurement somehow collapses a realm of possibilities into a single actuality. But when exactly does this collapse occur? And what does when even mean in a context where time itself might be quantized or emergent? Quantum theory gives us a mathematical framework called the wave function, a mathematical entity that describes not what is, but what could be. Before measurement, a quantum system exists in a superposition of all possible states, weighted by probability. The mathematics works perfectly, predicting experimental results with astonishing accuracy. But what does the wave function actually represent? Is it merely a calculational tool, or does it describe something physically real? If it's real, then reality itself might be less concrete than we imagine, more like a cloud of possibilities than a definite thing. And if possibilities can exist in superposition, could time itself exist in multiple states simultaneously? Could there be a quantum superposition of time-like dimensions, some paired with space and others existing independently? Time loops. Closed. Time-like curves in the language of general relativity represent one of the most disturbing possibilities in theoretical physics. Unlike the linear time we experience, a closed time-like curve allows for travel into one's own past. Einstein's equations don't forbid such structures. In fact, certain exotic spacetime geometries seem to require them. Imagine a massive, infinitely long cylinder rotating at near light speed. The frame dragging effect, a real phenomenon where rotating masses pull space-time around with them, would become so extreme that paths through space-time could loop back upon themselves. In theory, you could follow such a path and meet your younger self. The paradoxes this would create, the grandmother paradox being the most famous, violate causality, the principle that causes must precede effects. Yet the mathematics allows it. Some physicists, including the renowned Kip Thorne, have suggested that quantum effects might prevent such causality violations, creating a chronology protection mechanism that preserves the sanctity of cause and effect. But others argue that causality itself might be an emergent property rather than a fundamental law, a statistical tendency that dominates at macroscopic scales but breaks down at the quantum level. The Wheeler-DeWitt equation, an attempt to merge quantum mechanics with general relativity, leads to a stunning conclusion. Time might not exist at the most fundamental level of reality. This problem of time emerges because the equation doesn't contain the variable t, time, at all. When applied to the entire universe, it suggests a static, timeless state. This doesn't mean nothing happens. Rather, it implies that change itself might be an illusion, arising from how we, as observers embedded within the universe, perceive reality. It's as if the universe is a vast, static pattern, and our consciousness creates the experience of time by moving through it in a particular way. This view reconciles with the block universe theory, but takes it a step further. Time isn't just fixed. It's not even a primary feature of reality. If time is emergent rather than fundamental, could it emerge without space? To answer this, we must understand what emergence means in physics. Temperature is an emergent property. It describes the average kinetic energy of particles, not a fundamental aspect of reality. Consciousness might be emergent, arising from neural activity without being encoded in any individual neuron. Similarly, both space and time might emerge from more basic structures, perhaps quantum bits of information or abstract mathematical relations. Theoretical frameworks like loop quantum gravity suggest that space-time itself is constructed from more fundamental entities called spin networks or spin foams, discrete quantum structures that aren't in space and time but rather constitute space and time. In such a framework, time and space emerge together from timeless, spaceless quantum geometry. But these theories also hint at asymmetries between time and space that might allow one to exist without the other under certain conditions. Imagine the universe as a quantum computer executing a vast calculation. The steps in this calculation create what we experience as the flow of time, while the relationships between computational elements create what we perceive as space. This isn't merely a metaphor, it's a serious proposal in the field of digital physics. If reality is, at its core, informational rather than material, then space and time themselves might be constructs, ways of organizing and processing quantum information rather than fundamental dimensions. In such a model, time could potentially exist in purely informational realms without spatial extent. The evolution of quantum states would constitute a form of time even in the complete absence of spatial dimensions. The multiverse theory, once considered fringe speculation, has gained substantial traction among cosmologists and quantum theorists alike. In the many worlds interpretation of quantum mechanics, every possible outcome of every quantum event spawns a new universe. If true, there exist infinite versions of you, reading infinite variations of these words, in universes that might differ in profound ways or only in the position of a single particle. Some of these universes might have different physical constants or even different physical laws. Could there exist universes with different dimensional structures, perhaps with multiple time dimensions, or with time but no space? The mathematics doesn't rule it out. In fact, string theory, our leading candidate for a unified theory of physics, requires extra dimensions beyond the four we perceive. Most of these are thought to be spatial dimensions, compactified to submicroscopic scales, but some variations of the theory explore the possibility of multiple temporal dimensions. The Hartle-Hawking no-boundary proposal suggests that asking what happened before the Big Bang is like asking what's north of the North Pole. The question itself becomes meaningless. In this model, time emerges from a primordial state where it was effectively absent, becoming more timelike as the universe expands. Near the Big Bang singularity, the distinction between space and time blurs completely. It's not that time didn't exist. It's that time as a distinct dimension hadn't yet emerged from the quantum foam of the early universe. This model suggests that time might be more fundamental than space, since it emerges first from the primordial quantum state. If so, could there exist states of reality where time has emerged but space has not? States where change occurs, where cause precedes effect, but where there is no where, only when. Now we stand at the precipice of understanding, where certainty gives way to mystery, and paradox reigns supreme. The questions we face no longer yield to simple answers, if they yield at all. We enter the realm of cosmic koans, puzzles designed not to be solved but to shatter our limited ways of thinking. And in that shattering, perhaps we'll glimpse the true nature of reality, beyond the comfortable illusions of space and time that structure our everyday experience. The Zeno's paradox of time presents a disturbing riddle. How can time flow if each moment must be preceded by an infinite number of ever smaller moments? To move from one second to the next, must we not first reach the halfway point? And before that, the quarter-way point? And before that, the eighth? This infinite regression suggests that motion, and by extension, time itself, should be impossible. The mathematical solution involves limits and convergent series, but the philosophical question remains: is time infinitely divisible? Or does it come in discrete units, quantum packets of duration below which it cannot be subdivided? If the latter, then time has a fundamental grain to it, a minimum unit that cannot be split. This quantization of time would have profound implications for whether time could exist without space. If both are they quantized together, as aspects of the same fundamental entity? Or could quantized time exist without quantized space? The whole argument, first proposed by Einstein and later developed by philosopher John Earman, reveals a profound ambiguity in how we understand space-time. Consider a universe identical to ours, except that all events are shifted slightly in space and time, not relative to each other, but relative to some absolute coordinate system. Would this be a different universe, or just a redescription of our own? If the latter, then space-time points themselves have no inherent identity. Only the relationships between events matter. This relational view of space-time suggests that neither space nor time exists as an absolute background against which events occur. Rather, they emerge from the network of causal relationships between events. In such a framework, asking whether time could exist without space might be asking the wrong question. Perhaps the right question is, could a network of causally related events exist without spatial relationships between them? Could there be a when without a where? The Boltzmann brain paradox asks why, if our universe tends toward disorder as entropy increases, we find ourselves in a highly ordered state rather than a state of maximum entropy. One disturbing possibility is that we don't, that our apparent cosmos, with its billions of galaxies, is actually a momentary random fluctuation in an otherwise chaotic system. Just as a room full of air molecules might, through sheer chance, all move to one corner for an instant, perhaps our ordered universe is simply an exceedingly rare fluctuation in an eternal sea of chaos. More disturbing still, it's statistically more likely for a single brain with false memories to fluctuate into existence than for an entire ordered universe to appear. Are you such a Boltzmann brain, floating in a void with illusory memories of a cosmos that never existed? If so, then space as you perceive it is entirely within your deluded consciousness, while time, the flow of mental states, might be the only real dimension you inhabit. Consider the information loss paradox of black holes. When matter falls into a black hole, all its information, the precise quantum state of every particle, seems to vanish forever once it crosses the event horizon. Yet quantum mechanics insists that information cannot be destroyed. This contradiction led to a decades-long debate among the world's leading physicists, including Stephen Hawking and Leonard Susskind. The proposed resolutions, black hole complementarity, firewalls, soft hair, all suggest revisions to our understanding of spacetime at the most fundamental level. Some theories propose that information is stored at the event horizon as two-dimensional, holographic data. Others suggest that space inside a black hole connects to new regions of spacetime through wormholes, as described by the ER-EPR correspondence. In all these speculative frameworks, space and time behave in ways that challenge our intuitions and raise the possibility that they might not be equally fundamental. The dark energy mystery presents another cosmic puzzle with profound implications. Observations indicate that the universe's expansion is accelerating, driven by an unknown force permeating empty space. If dark energy maintains its current strength, the cosmos faces a heat death, a future where galaxies recede beyond visual range, stars burn out, and even matter itself may eventually decay. In this scenario, the universe approaches a state of perfect homogeneity, where nothing happens and nothing changes. Would time still exist in such a static, empty cosmos? If there's no change, no process, no evolution of states, can we meaningfully speak of time? Or would time itself cease to exist, leaving only an eternal, unchanging spatial void? This thought experiment suggests that time might depend on change rather than on space, that it might indeed be possible for space to exist without time, but not vice versa. The cosmic censorship hypothesis, proposed by Roger Penrose, suggests that singularities are always hidden behind event horizons, preventing the rest of the universe from witnessing the breakdown of physics that occurs there. But there's no mathematical proof that this must be true. If naked singularities could exist, points where space-time curvature becomes infinite without the shroud of an event horizon, then causality itself might break down in regions of our universe. Near such a singularity, effects might precede causes, and the distinction between past and future could dissolve completely. Some theorists have suggested that quantum effects would prevent such causal violations, but others argue that regions might exist where time behaves fundamentally differently than in our familiar realm. These exotic possibilities hint at the diversity of temporal structures that might exist across the cosmos, some perhaps divorced entirely from spatial extension. The problem of now presents another profound puzzle. Why does one moment, the present, feel special among all moments? In time? In the block universe model, all moments exist equally, yet we experience only one thin slice of this eternal structure as now. There's nothing in our physical theories that explains this asymmetry, this sense of a moving present. Some philosophers, including John McTaggart, have argued that time itself is unreal precisely because of this contradiction between our experience of time and its mathematical description. Others, like philosopher of physics Tim Maudlin, argue that time's passage is primitive and irreducible, a fundamental aspect of reality that cannot be expressed in purely spatial or mathematical terms. If time's flow is indeed something beyond mathematics, something qualitatively different from spatial dimensions, then perhaps it could exist independently of space. A pure becoming without being, a flow without a channel. The 11th dimension. Paradox emerges from M-theory, the framework that unifies the various string theories. M-theory requires 11 dimensions, 10 of space and 1 of time. But why this asymmetry? Why not multiple time dimensions? Some theoretical physicists, including Itzhak Bars at USC, have explored the possibility of two-time physics, where our universe has two temporal dimensions rather than one. The mathematics of such theories is consistent, though extraordinarily complex. Multiple time dimensions would create new types of causality and new forms of determinism unlike anything in our experience. But they also suggest that time and space might not be as different as we imagine, that our perception of a single time dimension might be a limited perspective on a more complex dimensional structure. If so, then asking whether time could exist without space might be like asking whether length could exist without width, a question based on an artificially limited understanding of dimensionality. The observer selection effect introduces a disturbing possibility. What we perceive as fundamental laws of physics might be mere artifacts of how we observe the universe. We can only exist in regions of the cosmos that support the complex chemistry of life, so we necessarily find ourselves in a universe with physical constants conducive to our existence. Applied to the question of time and space, this suggests that we might perceive these dimensions as inseparable simply because observers capable of asking the question can only arise in regions where both exist. Perhaps in other regions of a vast multiverse, time exists without space, but no one is there to observe it. This isn't mere speculation. It's a serious consideration in cosmology known as anthropic reasoning, and it suggests that our most fundamental intuitions about reality might be severely biased by the conditions necessary for our existence. The Gödel universe presents another challenge to our understanding of time's nature. Kurt Gödel, the same mathematician who proved that any sufficiently complex mathematical system contains unprovable truths, discovered a solution to Einstein's field equations describing a rotating universe where closed timelike curves exist everywhere. In such a universe, you could always find a path through spacetime that returns to your starting point in both space and time. This would make time travel not just possible, but inevitable. Causality as we understand it would be meaningless, as every effect could be its own cause. Einstein was deeply troubled by this solution, as it suggested that time as we experience it, with its rigid distinction between past and future, might be an illusion rather than a fundamental feature of reality. The Gödel universe remains a mathematically valid solution to Einstein's equations, reminding us that our intuitive understanding of time might be hopelessly inadequate. The final paradox we'll consider is perhaps the most disturbing: the hard problem of time. Just as consciousness presents a hard problem, how does subjective experience arise from physical processes? Time presents us with a similar conundrum. Why do we experience time's passage at all? Why does reality seem to evolve from moment to moment rather than existing all at once? No purely physical theory explains this subjective experience of time's flow. Some theorists, including philosopher Hugh Price, have suggested that the direction of time might be a psychological construct rather than a physical reality, that past and future are ultimately symmetric at the fundamental level, and the apparent asymmetry is created by our minds. If so, then time as we experience it might indeed be separable from physical space, a construct of consciousness that could theoretically exist in non-spatial realms. The flow of thought, the sequence of mental states, might constitute a form of time even in the complete absence of spatial extension. As we confront these paradoxes and unsolved questions, we begin to see that the relationship between time and space is far more complex and far more mysterious than our everyday experience suggests. The mathematics of modern physics points toward possibilities that defy our intuitions and challenge our most basic assumptions about reality. Whether time could exist without space remains an open question, one that may require new mathematics, new physical theories, or even new ways of thinking to resolve. But the journey toward an answer reveals the astonishing depth and complexity of the cosmos we inhabit, a reality far stranger and more wonderful than we ever imagined. We've been examining the cosmos through the lens of equations and theories, but now let's confront something far more immediate. What these possibilities mean for you, for your existence, your memories, your sense of self. If time could exist without space, you might be more than just a physical being moving through 4 dimensions. You might be something far stranger, a pattern of information, a sequence of states, a story told in a language we haven't yet discovered. Consider this. You believe you were born, that you've lived a continuous life, and that someday you will die. But what if time is an illusion? What if, as the block universe suggests, your birth, your death, and this very moment of realization all coexist eternally? Every decision you've ever agonized over, every mistake you've regretted, every Triumph you've celebrated, all frozen in an unchanging cosmic tableau. Your consciousness isn't moving through time. It only seems that way from your limited perspective. Everything you've ever done might have already happened infinite times before. Everything you will ever do is already written in the cosmic script. Are you still the author of your life? Or merely an actor reading lines already composed in the timeless substrate of reality? Now imagine your consciousness not as a continuous thread, but as a series of discrete moments, each a complete universe unto itself. Each instant of awareness exists independently, linked only by memory and anticipation, neither of which, necessarily, reflects reality. The you that existed 5 seconds ago is as dead as the you from childhood. The you that will exist 5 seconds from now is as unborn as your grandchildren's grandchildren. Only the present moment exists, and it exists without duration, a razor's edge between a past that no longer exists and a future that does not yet exist. If time is quantized, then consciousness itself might be a series of snapshots rather than a continuous flow. Your sense of self, that feeling of being a single entity persisting through time, might be nothing but an illusion created by memory. If time could exist without space, would your consciousness still require a brain to house it? Or could it exist as pure sequence, pure becoming, without any physical substrate? What if the universe is alive, and we are just its fleeting thoughts? Consider, your body contains trillions of cells, each alive in its own way, each executing its genetic programming without awareness of you. The emergent consciousness that arises from their collective activity. Perhaps humanity, perhaps all conscious beings throughout the cosmos, stand in similar relation to some vast cosmic consciousness that emerges from our collective existence. Our lives might be to this cosmic mind what our individual thoughts are to us, transient, purposeful in the moment, yet ultimately forgotten as new thoughts arise. If time could exist without space, perhaps this cosmic mind exists primarily in the temporal dimension, experiencing the universe not as extension, but as pure becoming, pure story. The entropy of the universe increases inexorably. Every ordered system degrades into disorder. Every structure eventually collapses. Every pattern ultimately dissolves. This isn't merely a physical law, it's the fundamental rhythm of existence itself, the baseline against which all our striving and creating and loving plays out. In the deep future, when the last stars have burned out and even black holes have evaporated through Hawking radiation, what will remain of all we've built? When matter itself may decay into radiation, and radiation diffuses into the ever-expanding void, will anything remain of human civilization? Of Earth? Of you? If time continues after space has been stretched into nothingness, will there still be something, some pattern, some record, some echo that remembers what once was? Look at your hand. Really look at it. The atoms that compose it were forged in the hearts of dying stars billions of years ago. The carbon in your cells was synthesized in stellar furnaces that exploded long before the Earth formed. The water that comprises most of your body once flowed through the bodies of dinosaurs, of ancient trees, of the first single-celled organisms that emerged from the primordial oceans. Your physical existence connects you to the entire history of the cosmos. But what of your consciousness? If time could exist independently of space, perhaps consciousness too transcends the physical. Perhaps it exists primarily in the temporal dimension, participating in space only temporarily through the vehicle of your body. Your awareness might be less a product of your brain than a visitor to it, a pattern in time that briefly interacts with matter before continuing on its journey through dimensions we cannot perceive. The scale of cosmic time dwarfs human comprehension. 100 years, a long human life, is less than an eye blink in cosmic history. The 13.820 Arnweti, keen 8 billion years since the Big Bang is itself a fraction of the time that lies ahead. Trillions upon trillions of years during which the universe will continue to expand. Stars will burn out, galaxies will disperse, and even matter itself may decay. What meaning can human endeavors have against such a backdrop? If you stood outside of time and witnessed the entire cosmic drama from beginning to end, would human civilization register at all? Would you even notice that brief flicker of complexity that arose on one tiny planet orbiting an ordinary star in an unremarkable galaxy? And yet, paradoxically, it is only through consciousness, through beings like us, that the universe can know itself at all. We are the cosmos become aware of itself, the mechanism through which reality contemplates its own existence. If time could exist without space, perhaps consciousness could as well. And perhaps that disembodied awareness would be the ultimate legacy of physical life. The thought that you might be nothing more than a temporary pattern in the cosmic substrate can induce a kind of existential vertigo, a sudden, disorienting awareness of the abyss that lies beneath all our comfortable assumptions about reality. You've built your life on the belief that you are a discrete entity moving through time and space, making choices that matter, affecting a world that exists independently of your perception. But quantum physics suggests otherwise. It hints that observation creates reality, that nothing is determined until it's measured, that the universe exists in a state of profound indeterminacy until consciousness interacts with it. If true, then you are not merely a witness to reality. You are its co-creator. Your observations collapse quantum possibilities into actualities. Without consciousness, without observation, perhaps the universe would remain an untold story, a book with pages of pure potential, never reduced to the finality of a single narrative. Now, here's the true cosmic horror. What if you're utterly alone? What if yours is the only consciousness in an otherwise mechanical universe? What if every person you've ever loved, every connection you've ever felt, every moment of communion with another mind was an illusion, a sophisticated simulation generated by your own consciousness to protect itself from the unbearable solitude of being the universe's only witness? This is solipsism, the philosophical position that only your own mind can be known to exist. It cannot be disproven, for any evidence against it would necessarily be perceived through the very consciousness whose uniqueness is in question. If time could exist without space, and if consciousness exists primarily in the temporal dimension, perhaps you are that time without space, a disembodied awareness dreaming itself into existence within a spatial hallucination of its own creation. Or perhaps the truth is even stranger. What if you are not one, but many? What if your consciousness is distributed across multiple universes in the multiverse, each version experiencing a slightly different reality? What if your sense of being a unified self is merely the result of these parallel consciousnesses remaining, quantum coherent, entangled across dimensional boundaries we cannot perceive? Each choice you make might split reality, creating new branches of the cosmic tree where different versions of you experience different consequences. If time could exist without space, perhaps your consciousness exists in pure, time-like dimensions that intersect with spatial reality only at specific points, moments of decision where the multiverse branches and new possibilities emerge. Seize Questions we've explored aren't merely academic puzzles. They strike at the very heart of what it means to be human, to be conscious, to exist at all. The relationship between time, space, and consciousness may ultimately determine whether anything we do has meaning, whether our lives are our own to direct, whether death is truly the end or merely a transition to another state of being. As you contemplate these possibilities, remember, you are the universe questioning itself. You are atoms arranged in such a way that they can contemplate atoms. You are time and space folded into a configuration that can wonder whether time could exist without space. And in that wonder, in that questioning, you may come closest to understanding what reality truly is. We've journeyed across the cosmos, from quantum realms to galactic superclusters, from the first femtosecond after the Big Bang to the distant death throes of the universe. We've questioned whether time could exist without space, peering into the mathematical crevices where our understanding breaks down. Now, as countless stars blaze against the darkness, as galaxies spiral in their slow cosmic dance, we arrive at a revelation that will transform everything we've discussed. A possibility so profound, it reshapes not just our understanding of reality, but our place within it. What if time doesn't just exist without space? What if time created space? Imagine the cosmos not as a four-dimensional manifold where time and space exist as equals, but as an evolving computational process where time is the fundamental reality and space merely its creation. In this view, the three-dimensional world, you perceive the solidity of matter, the vastness of cosmic voids, the very ground beneath your feet, would be an emergent property, a projection from a more fundamental temporal substrate. This isn't mere speculation. Recent theoretical work in quantum gravity suggests that spacetime itself may be encoded in quantum entanglement, that the fabric of reality emerges from pure information rather than existing a priori. Watch as galaxies collide in slow motion, their spiral arms intertwining like cosmic dancers. See the shock waves ripple through interstellar gas, igniting new stars in brilliant bursts of creation. These majestic structures exist in space, yes, but they evolve through time. And if time is primary, then perhaps these spatial phenomena are not things in themselves, but patterns of temporal evolution, like ripples on the surface of a cosmic ocean, revealing the currents flowing in the depths below. Consider the holographic principle, which suggests that all the information contained in a volume of space can be encoded on its boundary surface. This radical idea emerged from studies of black holes, where the entropy, the information content, scales not with volume but with surface area. Applied to the entire universe, this principle suggests that our three-dimensional reality might be encoded on a two-dimensional surface, like a hologram projecting the illusion of depth. But this hologram doesn't just encode spatial information, it encodes temporal evolution. The surface doesn't just describe what is, but what becomes. In this framework, time isn't just another dimension. It's the process by which information unfolds, the algorithm that transforms potential into actuality. Now, here's the twist that will shatter your understanding. What if the universe is already dead, and we are just experiencing its last echoes? What if the cosmos as we know it, all of space and everything in it, is a vast quantum memory storing the final moments of a reality that has already ended? Imagine a universe that has reached its final state, perhaps through heat death, where entropy has reached its maximum and no further change is possible. In such a state, time effectively ends, as there can be no further evolution of systems. But what if, in that final moment, the universe performs one last quantum measurement, ATE, retrospective observation of its own history. In quantum mechanics, observation collapses probability into actuality. Perhaps our experienced reality, the entire cosmic history from Big Bang to whatever end awaits us, is actually the result of this final observation, a retrospective creation of a past that leads inevitably to that ultimate state. This would mean that we don't live in a universe evolving forward in time, but in one reconstructing itself backward, creating the illusion of temporal flow as quantum information decompresses from its final state. The arrow of time that we experience, the apparent flow from past to future, would actually be the reverse of a more fundamental process, the universe remembering its own history. See the cosmic microwave background radiation, that faint glow, permeating all of space, the oldest light in the universe. We interpret it as an echo of the Big Bang, the afterglow of creation. But what if it's something else entirely? What if it's the first whisper of the universe's final state reaching back through time, establishing the initial conditions that will inevitably lead to that end? What if the beginning and the end are actually the same moment, viewed from different perspectives in a cosmic loop where time doesn't just curve, but closes upon itself? Galaxies wheel through the void, their spiral arms tracing paths through space like the hands of cosmic clocks. Supernova explosions bloom in silent fury, scattering the elements of life across interstellar distances. Black holes devour stars, warping space-time around them until reality itself seems to tear. These processes unfold in time, yes, but what if time itself unfolds from something deeper still? What if the fundamental reality isn't temporal or spatial, but informational, a vast quantum computation that doesn't occur in time, but creates time as it executes? This perspective transforms our question from, could time exist without space, to something far more profound. Does space exist at all, or is it merely a construct of temporal processes? If reality, at its most fundamental level, is pure information, evolving according to quantum algorithms, then neither time nor space, as we understand them, would be primary. They would be emergent properties, useful approximations that allow embodied consciousness to navigate a small corner of a far stranger reality. Look out at the night sky. Those stars you see, many are already dead, their light only now reaching your eyes after journeys of hundreds or thousands of years. When you observe a distant galaxy, you're not seeing it as it is now, but as it was millions or even billions of years ago. Your perception of the cosmos is inherently retrospective, a collection of light from different times, creating the illusion of a simultaneous spatial arrangement. What if the entire universe operates this way? What if all of reality is a retrospective reconstruction, not just from our limited perspective, but fundamentally at the quantum level? The implications are staggering. If we exist in a universe that is essentially remembering itself from its end state, then the future doesn't just influence the present, it creates it. Causality as we understand it would be an illusion, a side effect of how information unfolds from a final quantum state of maximum entropy. Free will, that most cherished of human qualities, would seem impossible in such a deterministic setup. And yet, paradoxically, quantum indeterminacy might still leave room for genuine choice, for moments where the retrospective creation of history remains genuinely open to multiple possibilities. Contemplate the darkness between galaxies, the vast cosmic voids where matter is scarce and space stretches emptily for hundreds of millions of light years. These voids aren't truly empty. They contain dark energy, that mysterious force driving the universe's accelerating expansion. What if these voids are where the illusion of spatial reality begins to break down? What if, in these empty regions, we could glimpse the truth? That space is merely a projection, a hologram cast by temporal processes occurring in a more fundamental substrate. As we reach the end of our cosmic journey, one haunting possibility remains. If time is primary and space emergent, if the universe is remembering itself backward from its final state, if reality is fundamentally informational rather than material, then perhaps consciousness itself is not what we think. Perhaps awareness isn't something that happens within space and time, but the process by which space and time are created. Perhaps you are not in the universe is in you, and if the multiverse theory is correct, if reality branches with every quantum decision into infinite parallel worlds, then somewhere out there exists a version of you who already understands all this, who sees beyond the illusion of space-time to the informational reality beneath. And somewhere else, another version of you is only now beginning to wonder whether time could exist without space, starting the journey we've just completed. If consciousness is primary and reality emergent, then these aren't different versions of you. They're different perspectives of a single consciousness, viewing reality from different angles in a cosmic hall of mirrors where everything that can happen, does happen, has happened, and will happen again, eternally. Our journey has taken us to the farthest reaches of theoretical physics and the deepest questions of existence. We've traversed the landscape of space-time from its quantum foundations to its cosmic structure. We've peered into black holes where time stands still, witnessed the birth of the universe where time and space emerged from quantum nothingness, and contemplated the possibility that time might be more fundamental than space, perhaps even its creator. But like all great explorations, we haven't reached a destination so much as discovered new horizons. The cosmos remains an open question, a mystery whose ultimate nature may forever exceed our grasp. And yet we continue to reach, to question, to imagine possibilities beyond our current understanding. This is the essence of the human spirit, not to know all answers, but to never stop seeking them. We began by asking whether time could exist without space. We've seen how Einstein's relativity binds them together as aspects of a unified space-time, how quantum mechanics suggests they might emerge from more fundamental processes, how black holes and the early universe point to conditions where the distinction between them blurs into meaninglessness. We've explored the block universe where time doesn't flow, but simply is, and contemplated the possibility that our experienced reality might be a retrospective construction, the universe remembering itself from its end state. These aren't mere intellectual curiosities. They strike at the heart of what it means to exist, to be conscious, to be human. If time and space are emergent rather than fundamental, what does that imply about consciousness, which seems so intimately tied to our perception of temporal flow? If reality at its deepest level is informational rather than material, could consciousness itself be a fundamental feature of the cosmos rather than a quirk of neural complexity? These questions don't just reshape our understanding of physics, they redefine what it means to be. Gaze upon the cosmos with new eyes now. That starry night sky isn't just a collection of distant suns. It's a window into the nature of reality itself. Each photon that strikes your retina has traveled across vast gulfs of space and time, carrying information encoded in its quantum state. The light from distant galaxies began its journey millions or billions of years ago, long before human civilization arose, perhaps even before Earth itself formed. When you look up, you're not just seeing objects in space, you're looking backward. In time, witnessing the history of the universe unfolding before your eyes. This cosmic perspective changes everything. Your daily concerns, your personal struggles, even your greatest ambitions, all exist within this vast framework of space-time. And yet, paradoxically, it is only through conscious minds like yours that the universe can contemplate itself. You are not separate from this cosmic drama. You are an essential part of it, the means by which the universe achieves self-awareness. Perhaps this is why consciousness evolved in the first place. Not merely as a survival mechanism for complex organisms, but as the universe's way of understanding itself. Now, consider this chilling possibility. What if consciousness isn't something that exists within time, but something through which time itself flows? What if your awareness isn't a product of neural activity happening in time, but the thread upon which the moments of your life are strung like beads? This would mean that your conscious experience, your sense of being a continuous self moving through time, is more fundamental than the physical processes we typically assume create it. It would mean that you aren't in time. Time is in you. If this seems impossible, remember that quantum mechanics has already shattered our intuitive understanding of reality. The double-slit experiment shows that particles behave differently when observed, as if the act of measurement itself collapses probability into actuality. Some interpretations of quantum mechanics, including the renowned von Neumann-Wegener interpretation, suggest that consciousness itself might be the agent of this collapse. If so, then conscious observation doesn't just perceive reality. It participates in creating it. The line between observer and observed blurs, just as the distinction between time and space dissolves at the quantum level. The universe exists in a state of profound interconnectedness. Every particle that comprises your body was forged in the heart of a dying star. The light that allows you to see has traveled across the cosmos, interacting with countless atoms before reaching your eyes. The air you breathe contains molecules that have cycled through billions of other living beings throughout Earth's history. You are not merely in the universe, you are of it, inseparable from the cosmic web of cause and effect that stretches from the Big Bang to the present moment, and beyond. And yet, despite this interconnectedness, each conscious perspective remains unique. Your experience of this moment is yours alone, a singular vantage point on the universe that no other being shares precisely. If consciousness is fundamental rather than emergent, if it exists at the level where time and space themselves are, created rather than within them, then perhaps these individual perspectives aren't as separate as they seem. Perhaps they're more like different windows looking into the same room, different angles on a unified consciousness that pervades the cosmos. This brings us to the very edge of science, where physics meets philosophy and mathematics blends with metaphysics. It's a frontier not just of knowledge, but of imagination. A realm where we must think beyond our evolved intuitions to grasp possibilities our minds weren't designed to comprehend. But isn't this the great adventure of human thought? To transcend our limitations, to reach for understanding beyond our grasp, to continually redefine what is possible? The questions we've explored don't have final answers, at least not yet. They remain open invitations to wonder, to theorize, to imagine. Perhaps they will always remain partially beyond our comprehension, like horizons that recede as we approach them. Or perhaps future breakthroughs in physics, in mathematics, in our understanding of consciousness, will illuminate these mysteries in ways we cannot currently foresee. Either way, the journey continues. The quest to understand reality at its most fundamental level, to comprehend our place within the cosmic order. What role will you play in this ongoing story? Will you be a passive observer, content to let others probe these depths? Or will you join the exploration, bringing your own unique perspective to bear on these cosmic questions. You don't need to be a physicist or a philosopher to participate. The contemplation of these mysteries is open to all. Indeed, it may be that fresh perspectives from outside traditional disciplines will provide the insights needed to move our understanding forward. Discuss these ideas with others. Share your thoughts, your intuitions, your questions. The collective intelligence of humanity far exceeds that of any individual. Throughout history, our greatest breakthroughs have come not from isolated genius, but from the interplay of many minds working together, building upon each other's insights, challenging each other's assumptions. The mystery of time and space, whether one could exist without the other, whether both emerge from something deeper still, is too vast for any single perspective to encompass. Look again at your own experience of time. Notice how it varies, how it seems to slow during moments of danger or intense concentration, how it speeds up during periods of engagement and flow. Consider how your perception of time changes as you age, as you learn, as you direct your attention in different ways. If time is not an absolute, but a relationship, a connection between events, between states of consciousness, then perhaps your subjective experience of temporal flow offers clues to its true nature that no equation can capture. As our exploration draws to a close, one final question emerges, perhaps the most disturbing of all. What if time itself is running out? Not just for human civilization or for Earth, but for reality as we know it. Recent cosmological observations suggest that the universe's expansion is accelerating, driven by mysterious dark energy that comprises nearly 70% of the cosmic energy budget. If this acceleration continues, eventually all galaxies beyond our local group will recede beyond our cosmic horizon, becoming forever unreachable, even by light. The universe will grow colder, emptier, darker, until even the matter that comprises stars and planets decays into radiation, and that radiation diffuses into an ever-expanding void. This heat-death scenario presents a profound challenge. If time is defined by change, by the evolution of systems from one state to another, what happens when all possible change has occurred? When entropy reaches its maximum and no further transitions are possible? Would time itself end, or would it continue meaninglessly, an empty dimension with nothing left to measure? Perhaps this end state is precisely the condition from which our experienced reality is being retrospectively constructed. The final observation that collapses quantum potential into the actuality we call history. But there's another possibility, one that offers a glimmer of hope amid cosmic despair. If consciousness is fundamental rather than emergent, if it exists at the level where time and space themselves are created, then perhaps it transcends the physical universe and its ultimate fate. Perhaps consciousness continues beyond the death of any particular cosmos, persisting in realms we cannot currently conceive, time-like dimensions beyond our familiar four-dimensional space-time, informational structures that survive the dissolution of matter and energy. The question of whether time could exist without space has led us not to a definitive answer, but to a deeper questioning of reality itself. And perhaps that's fitting. The cosmos didn't reveal all its secrets at once to our ancestors, and it won't to us either. Each generation reaches a little further, sees a little more clearly, asks more profound questions than the last. We stand on the shoulders of all who came before us, peering into abysses of space and time that they couldn't have imagined. And future generations will stand upon our shoulders, venturing into conceptual territories we can barely conceive. Remember this as you continue your own journey of discovery. The universe may have no edge, but that doesn't mean it has no center. Every point in the cosmos is equidistant from its boundary, which means that wherever you stand at the center of all things. Your perspective matters. Your questions matter. Your consciousness, that mysterious awareness through which time might flow, matters. The story of the cosmos remains unfinished. The relationship between time, space, and consciousness continues to evolve with our understanding. And you are not merely a passive reader of this cosmic narrative, but an active participant in its unfolding. The universe speaks the language of matter and energy, of quantum fields and curved spacetime, but it hears through conscious minds like yours. So look up at the stars tonight with new awareness. What you see isn't just out there, it's also within you. The boundary between observer and observed is more permeable than we once believed. The distinction between time and space may be less fundamental than we thought. And the mystery at the heart of existence, whether time could exist without space, whether consciousness could exist without either, remains an open invitation to wonder. The cosmos has no final answer, but perhaps neither do you.